All right, next part, vertical line test. If every vertical line intersects a graph at no more than 1 point, then the graph represents a function. So no more than 1 is a function. More than once it does not represent a function. It's just a relation. Only a relation.
Come in.
All right, so vertical line test should go fairly quick, right? Pretty straightforward. If you take a vertical line and you move it up and down and it only hits 1 point at a time, then it is a function. So example A, is it a function?
Yes.
Yes. Example B, is it a function?
No.
No. Yay, you have mastered the vertical line test. Good job. Okay. All right, next, represented by diagrams and equations, okay? There are 2 other ways that we can represent or define a function. Diagram, example 1, is a mapping, okay? With mapping, to determine whether it's a function or not, that means from your domain, only 1 arrow each. That makes it a function, okay? This is not a function. Why is it not? The X is repeat. It has more than 1 arrow coming from the domain, right? How do we feel? Any questions about understanding a function in domain in mapping form? Okay, now equations. When you're looking at an equation, the question is, can it be defined as y equals? Okay, so if I have the equation x plus y equals 1, I can rewrite it in terms of y, right? How can I rewrite it in terms of y? By isolating the y. So when I isolate the y, I had x plus y equals 1. I subtracted x from both sides. And I'm left with y equals 1 minus x. That means that it can be represented as a function, that this is a function. And that's because there's only 1 output for the input. Okay. So, class practice. Here, out loud. Is f equal 1, 2, 2, 2, 3, 2 a function or not?
Yes.
Why, yes, it is. Is g equal to 2, 1, 2, 2, 2, 3 a function?
No.
No, it's not. Is 4y equal x a function?
Is yes.
And why is it a function?
Because this is not with me.
Can I get y by itself?
Oh, yeah.
Yes, I can get y by itself by dividing by 4, right? So I get y equals x divided by 4. And this is a function because if I plug in 2, I'm only going to get 1 answer, right? If I plug in 3, I'm only going to get 1 answer. Okay. Next, is this a function? First thing you ask yourself, can you get y by itself? All right, let's see. So what are my steps to get y by itself? Subtract, right? Subtract the x squared. It's not PEMDAS. When you are solving, you go backwards. Okay, what's the next thing I gotta undo? How do you undo the square? You take the square root. When you undo the parenthesis, to undo a square, you take the square root. So you have y minus 3 equals. What happens when you take the square root of something? It takes away the 2, but what's your output? It could be a positive number or a negative number, right? Because the square root of 4 is technically positive 2 or negative 2, right? So it creates a plus or minus. What is the last thing I need to do to get y by itself? Add the 3, right? So we're left with y equals plus or minus the square root of 4 minus x squared plus 3. What makes this not a function is this guy, that plus or minus. That's what makes it not a function. Okay, it's not a function because my x values are going to repeat with that plus or minus. That plus or minus means that I'm gonna have to plug in 1 first time as a positive and solve it. Plug in 1 second time as a negative and solve it. And can you put the input in twice? It's not a function. Think about a vending machine. When you put in the money for the vending machine, do you get to make 2 input options? No. It doesn't function that way. Okay. All right. That concludes 1.3. How do we feel? Did it all feel familiar?